Okay, today we're going to talk about the Singleton pattern. The Singleton pattern is a creational pattern, and creational patterns abstract the instantiation process. Instantiation is just a fancy word for creating objects on the heap. These creational patterns help make a system independent of how its objects are created, composed, and represented. They encapsulate knowledge about which concrete classes the system uses. The creational patterns give flexibility in what gets created, who creates it, how it gets created, and when it is created. So to the singleton. There are many cases where you need to make sure there's only one instance of a class. If you're creating an object that represents a connection to a database, for example, those objects tend to be very expensive, both in memory, resources, and computation. So you want to make sure you only have at most one of them. Now this is actually a fairly common problem, that we have expensive objects, and this pattern addresses ensuring that we have at most one of these really expensive objects. To prevent instantiating the class more than once, we're going to use a trick. We're going to make the constructor of the class private. So an object can only be created from a static method inside the class. Well, that should make more sense when we look at some code. Then the class will hold a static reference to the one and only object of its type that's allowed to be created, and it will hand that reference off to anybody who wants it. Okay, so the intent of Singleton: ensure a class has only one instance and provide a global point of access to it. Okay, so it's important that some classes have exactly one instance. So some examples might be a print spooler that kind of queues up jobs to be printed. A window manager. Operating systems have window managers that control which windows get created. A file system. You for sure would only want your operating system to know about one file system. So how do we make an object easily accessible and guaranteed to have only one instance? Well, global variables are easily accessible, but they make no guarantees about single instances. A better solution is to make the class responsible for keeping track of its sole instance. So here's the class diagram for the singleton. It's very simple. We just have a class that is a singleton. It has a reference to a singleton. So down here we see a piece of data called instance. And instance is a reference to a singleton. It's a static reference. Again, remember what static means. A static piece of data is one that is shared by all the objects of a class. Or in other words, that piece of data belongs to the class. Normally, a non-static piece of data, each object gets its own copy. But with static data, all the objects share one. There's also a static method that returns a static reference. So that's what getInstance does. GetInstance returns a singleton object, okay, and it's static. So you don't need to have a singleton object. You could just say the name of the class.getInstance. Okay, so the way you get hold of a singleton is to use the static getInstance method. And again, I'll show you some code in a second. Okay, the consequences of using singleton. Well, we get controlled access to a sole instance of a class. This reduces global variables and the problems that come with them. And actually, we could modify singleton to permit any variable number of instances. So if for some reason we wanted to make sure there's never more than 2 instances or 10 instances, we can modify singleton to do that. Okay, so let's look at some code. Okay, let's use our file system example. So we want to make sure the file system class, we can only have one object of this type. Okay, so the steps are: we make a private static reference to a file system. So this might look odd that we have a reference of type file system inside the file system class, but that's totally legal. We call this reference instance, and we initialize it to null. So this reference is going to be a reference to the one shared file system object. Next, we make the constructor private. So this means no one can create a file system object except, one of the methods inside the file system class, which we'll see that happens down here. Okay, so we still probably want to initialize the file system. We would still do that in the constructor, but the constructor is private. Then we have a public static method called getInstance that returns a file system. Okay, this returns the reference to the one file system object in the system. And what do we do inside here? Well, we check to see, well, what is the state of instance? Is it still null? If it's null, that means nobody's called getInstance yet. And here's where we will create the one and only instance of a file system. We can do this. We can make this call to the constructor because it's in a method of the file system class. Okay, so we create the object and store it inside instance, and then we return instance. The next time somebody calls getInstance, this will be false because the instance will not be null anymore, and we'll just return the one instance that was created before. Okay, and then lastly, in any Singleton class, you can and should have additional stuff. In this case, this is file system related stuff. Open a file, close a file. Okay, so again, to make a class a Singleton, you have a private static reference called instance. You have a private constructor, and you have a public static getInstance method that checks to see is that instance null. If so, it'll create the one object and return it. Otherwise, it'll just return the one that was created previously. Okay, so if we were, imagine we were in some other part of the system here, and we wanted to call either open or close on the file system. The way we call a static method is we give the name of the class and the name of the static method. So if this happened to be the first time anyone was using the file system object, this point is where the file system object would be created. Okay. In the call to getInstance, if instance was null, this is where we'd create the file system, and the constructor would be called there. But for sure, the second call, the call to close, the constructors for the file system won't be called here because we know for sure the one and only file system object has already been created, and getInstance just returns a reference to that one object. So in open, that may cause the constructor to be called. Close and anyone after that will definitely not cause the constructor to be called. And you could test this out by putting a print statement in your constructor, or you can put a print inside this if and see exactly how many times that gets printed out. It should always be exactly once. Okay, let's look at another example. This time in C++. So we've probably all used the random number generator in C++. So let's look at this code and see what happens. So we have a main function, and 100 times what we're going to do is call print random, and this is supposed to print a random number. Okay, so let's look inside here. What do? Well, we seed the random number generator with the current time in milliseconds. So since the time is constantly changing, this should produce a different value for seeding the random number generator, and thus we should get different random numbers each time we call rand. Okay, if you run this program on many machines, you'll get 100 identical numbers. Okay, so that's not very random at all. The reason is that the processor is running so fast that the call to seed happens repeatedly in the same millisecond, producing the identical initial state for the random number generator. And since that seed value is so important to the algorithm, if we pass in the same seed number over and over again, we're going to get the exact same set of random numbers back. Okay, so we have a problem here. The fact that the processor runs very quickly, and the fact that our system clock is based on milliseconds rather than something smaller like nanoseconds. Okay, but this isn't a very object-oriented program. Let's look at maybe an equivalent C++ program that has classes. So now I'm going to create this class called random wrapper, which is just a wrapper around the call to the rand function. has a constructor and a method called getRand, which will return a random number. Okay, in the constructor, what we're going to do now is we're going to seed the random number generator, again using the current time. And when somebody wants a random number, they'll call the getRand function. Okay, let's look at the driver here. So main is the same. We're going to call print random 100 times. But now what we do is we create a random wrapper object called R, and we say r.getRand. Now this suffers from the exact same problem. We didn't solve anything here. We're creating multiple instances of the class, most likely in the same millisecond. So when we call getRand 100 times, we're going to get exactly the same random number back because now we have 100 random wrapper objects, and they all were seeded to the exact same millisecond time. So one solution might be to create the object in the calling method, in this case main, and pass it into print random. But who's to say that it's always going to be main that calls print random? It might be some other method that itself is called many times within the same millisecond. Okay, so just moving the declaration of R up to main or up to some other function doesn't necessarily guarantee that we're going to have pseudo-random numbers. It would be much better if we could somehow ensure there was only ever one random wrapper object in the system. So let's look at how we would do this in Java with the Singleton pattern. Okay, so now I'm going to call my class random generator, and again I'm going to follow that same pattern. Okay, we're going to have a private static reference of the same type of the class we're trying to create, random generator. It's going to be called instance, and we're going to set it to null. This will refer to the one and only random generator in the system. We make the constructor private, and here is where we would seed the random number generator. If this was the C++ program, this is where we do the call to srand. Okay. Then we have a public static getInstance method that returns a reference to the one and only random generator. Okay, and we check to see, have we created the one and only object yet? If not, the instance will be null, and we'll go inside this if here and create the random number generator. This is where the seeding is going to happen, the one and only time the seeding is going to happen. Every additional time we call getInstance, this will be false, and we'll just return the one reference that we created before. And then getRandom, of course, that's the equivalent of we'd have to call rand and return some number. Okay, so that's our second example of the Singleton. And again, these patterns, the solution is the same, but you have to apply them to your particular context a little bit differently, usually each time. Now there's another way to get Singleton behavior using a different pattern called the monostate pattern. Okay, so let's look at this alternative way. Let's imagine we had a class called foo, and foo has two data members, data1 and data2, with these two setters. Okay. If we created three distinct objects, f1, f2, and f3, point to the three foo objects. Each one of these objects will have its own data1 and data2. Right? So what we can do, if we wanted to simulate there only ever being a single instance, we could go to the foo class and make its data static. So remember what that means. That means there will only ever be one data1 and one data2. All objects will share the sole instances of data1 and data2. Okay. Now when we create three distinct objects, it's true they are all three distinct objects, but they all share a single copy of data1 and data2. So they are essentially the same foo object. Okay. So if all of the data in a class is static, that is essentially like making a singleton, because no matter what you do with f1, f2, and f3, okay, everybody is basically using the same data1 and data2 that's in the static data members.